Okay, so question 7 is, of course, from the old thing that, I don't know, maybe you don't do it anymore, but when I was a kid, we would always sing, and we thought this was very funny. Jingle bells, Batman smells, Robin laid an egg, Batmobile lost a wheel, and the Joker got away. And I think probably just did it to annoy our parents during Christmas season. I seem to recall Bart Simpson sang it once on an early season of The Simpsons. But anyway, it's not well known, but this is actually a factual account of a real encounter between Batman and Robin on one hand and the Joker on the other hand. And what happened was, as I said here, Robin laid his egg right as the Joker, took off from Gotham City Bank, accelerating at 3.0 meters per second squared down this perfectly straight street. It's true. Okay, so I'm going to go ahead and define that as, let's see, we're supposed to find out how long it takes Batman to catch the Joker. Batman spends some time replacing the wheel, and then he accelerates. So anyway, we're going to start with x equals 0, and this direction is going to be positive x. And so initially, let's see, initially we have the Joker here starting at 0. So Joker, I'll make green, initial velocity 0. Maybe I'll make that VJI is 0. And Joker's acceleration is 3.0 meters per second squared. And so we can actually just sort of write a formula here for the Joker's position. X for the Joker is going to be Joker's initial velocity times time. Well, actually, yeah. I get to really be sort of formally perfect about this, we should say that x for the Joker is initial x for the Joker plus Joker's initial velocity times time plus 1/2 acceleration of the Joker times time squared. But if the Joker starts at 0 and starts with a velocity of 0, then all that's left is this. So x for the Joker is 1/2 a for the Joker times t squared. Okay, now for Batman, Batman does all the same stuff, but he starts, he has a greater acceleration, and he has to spend 10 seconds replacing the Batmobile's wheel. Okay, so if I want to do Batman, I'll do Batman, and I should say black for Batman. Now Batman's gonna be blue. Oh well. Pretend it's the crappy old 70s TV show. So he's going to end up with the same thing, the same form, right? Because Batman starts at position 0 and velocity 0. Okay, acceleration of Batman. The only difference really is that Batman doesn't get started until t equals 10. So what's going to happen is Batman's position as a function of time is going to be, instead of using t there, we're going to use t minus t sub d, where t sub d is the delay time. Delay for Batman, okay? So we use this as Batman's time, and we just say when t is less than t sub d, this actually isn't valid. This is only valid starting at t equals t sub d and later, okay? So that's, of course, 10.0 seconds. And so what you get is Batman's position is going to be 1/2 times 5.0. So this is going to be 2.5 times t minus 10.0 squared. Okay, and for the Joker, I'll switch back to black here. X for the Joker is 1/2 times 3.0, which is 1.5 t squared. Okay, so actually I'm going to push this through all the way symbolically, or almost all the way. So what I'm going to do, instead of plugging in right now, I'm just going to, you could, but it's actually easier to solve if you don't plug in yet. And we're going to say when Batman catches the Joker, that's what we call an interception condition. You could call it intercept. That's not a formal term you have to know, so don't worry about that. That's when Batman's position and the Joker's position are the same. Okay, so what we do there is then we say we plug in this expression here for xb, and this expression here for xj, and then we get 1/2 ab t minus t sub d squared. Okay, Batman's position on the left, and then Joker's position on the right, which is 1/2 aj t squared. And then you can cancel the 1/2s, and what you get is, I mean, then it sort of turns into this expression. So I'm going to take the t minus t sub d squared on this side. I'm going to bring the t squared under it. Okay, and then I'm going to bring the ab under there. So it's aj over ab. And then it's sort of a matter of how far you want to take this before you plug numbers in. So what I'm going to do here is take the square root of both sides, okay? And this is supposed to be an arrow pointing toward another equation. I just can't write for crap. So I'm going to take the square root of both sides and get t minus td over t equals square root of aj over ab, okay? And then we simplify this out, and what we get is, I'm going to start all the way over here, we're going to get t over t is 1 minus td over t equals square root aj over ab, and then we get to, I guess what we'd have to do is do, let's take the negative both sides and move the 1 over. So this is going to be equal 1 minus square root of aj over ab. And right, and then so then I guess if we want to well, I mean, at this point, you know, I mean, look, I try to preach solving things symbolically first. So, you know, if you want to follow that philosophy, the thing to do would be to solve this for little t, which is what you're trying to find. But sometimes in practice, there's a point where you're just like, screw it, let's plug this in, okay? So I would say at this point, we've got it down to where we can plug this in, and this, and this, and this. You know, the 1. I mean, obviously you can plug 1 in, right? And just then get t out. So what I would do here is I would probably go with 10.0 over t equals 1 minus square root of aj over ab, and, you know, and then calculate. So, you know, for your calculator, plug this part in, and then divide it by 10 and flip it over to get your t. And I guess I can get my phone calculator out and do it. That's what I have handy. And ooh, sorry, text from my wife, and yeah, she just ordered pizza for us because she's coming home. Yes, haha, I get pizza. All right. So I'm gonna do the 1 minus. And it's so sad how excited I am about that. Okay, so square root of, and then let's see, aj was 3 and ab was 5, so it's 1 minus square root of 0.6, and that equals 0.225. So this right-hand side is 0.225. Oops, gotta get the pizza. Okay, pizza's here, but my wife is not yet, so you're in luck, because I will actually try to finish this problem. So this right-hand side comes out to, there we go, 0.2254. Okay, so now I'm going to, let's see, I'm going to try dividing that by, no, oh my gosh, okay, divide that by 10, and I get that. And then I'm going to try to take that to the, come on, no, -1, I hope this works, and what I get is 44.3, holy crap, is that right? 44 point, that seems, no, that can't be it. Well, I screwed something up. The question is, how much do I care? Let's see. Divided by 10. Boy, less and less. That pizza's smelling good, guys. So, well, the moral of the story is I screwed something up somewhere. Maybe if you are a clever reader, you will find what it is. Well, that's strange. Yeah, I don't know. Anyway, I got 40. I just got 44 seconds when I try to calculate this, and that is so wrong. But I really don't know what the answer is, and like I said, I just don't care at this point. So anyway, I think you see how to do it. You set these two equal, and then you solve this equation. And maybe it's better to just like, let me here. Maybe it's better to just take this equation here and solve it as a quadratic. And then plug numbers in at this point, solve as a quadratic. That's probably, well, it's probably less likely to screw you up. Anyway, enough about Batman the Joker. I am going to go eat. So maybe I'll do the graph problem later, or maybe not. Bye.